Dear students, I am Dr. Harold Thomas, Professor in Applied Geology, Department of Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Today, I will deliver my lecture on Albite, epidote, hornfels facies. I will cover this topic in two parts. In part first, I will proceed under the following heads: the introduction, difference between albite, epidote, hornfels facies and greensiss facies, characteristic minerals, general chemographic phase relations. Hope it will be useful for you. The contact or thermal metamorphic phases develop when hot magma, gabbro, syenite or granite intrudes the country rock at less or shallow depth of crust are considered as low pressure metamorphic phases. Usually, the load pressure is less than 4 kilobar, that is below the triple point of Al2SiO5. Thermal effects are generally more prominent in sedimentary rocks of shells and carbonates composition. The rock of areoles are called hornfels with granoblastic textures. Basic magma, gabbro usually show more thermal effects than granitic magma because of the initial high temperature. On the basis of the pressure and temperature, we can divide the metamorphic phases into three types, mainly A. Phases of low pressure, B. Phases of intermediate pressure, and C. Phases of high pressure. The phases of low pressure is on your screen based on Turner 1968. First, albite, epidote, hornfels facies. Second, hornblende, hornfels facies. Third, pyroxene, hornfels facies. Fourth, cyanidinite facies. If you will move from albite, epidote, hornfels facies to cyanidinite facies, the temperature of metamorphism increase from albite, epidote, hornfels facies to cyanidinite facies. This facies was introduced by Fye, Turner and Berrugan in 1958 to cover the mineral assemblages that sometimes appear in the outer fringe of contact areoles, and hence the mineral assemblages form at low temperature of about 300 to 400 degrees centigrade. Pressure also low in range of 100 to 3700 bars, that is less than 4 kilobars. Most of the understanding of the phases of low pressure is drawn from the contact areoles developed by Pluton at relatively high crustal evolution. Post-tectonic granite plutons cutting deformed geosynclinal basing, filling and Archean's greenstone belts, floor underlying massive Precambrian stratified mafic, ultramafic seeds injected into virtually undeformed basin, sediments and volcanics. The general metamorphic regime consequently is one of the low pressure, P commonly 2 kilobar or generally less than 3 kilobar, and temperature of the most part consistent with Ziegler models temperature 300 to 750 degrees centigrade. Facies therefore can be treated in simple sequence of increasing grade from outside inward in zoned areoles. Because of low temperature and low pressure, we observe quartz, mica and andalusite in peltic hornfels and spotted slates, albite, epidote, chlorite, actinolite in basic hornfels, epidote, calcite, tremolite in impure carbonate rocks. The mineral assemblages have much in common with those of green's facies. Indeed, it is only the difference of field occurrences that separate albite, epidote, hornfels facies. The peltic rocks are represented by peltic hornfels, and peltic hornfels contain quartz, mica, andalusite, stiplomylene and almandine garnet, which is present in the higher temperature part of the green's facies, is absent. Chloritoid is generally absent or very rarely present. Difference between albite, epidote, hornfels facies and green's facies. See the two columns: albite, epidote, hornfels facies and green's facies. Andalusite present, chloritoid absent, almandine garnet absent, and maculose texture present in albite, epidote, hornfels facies, while in case of green's facies, kyanite present, chloritoid present, garnet present in upper green's facies, and maculose texture is absent. In the peltic rocks, the assemblages quartz, muscovite, albite, biotite, andalusite. Characteristic of this facies: the common green's facies, mineral stiplomylene and almandine rich garnet are absent in this facies. Chloritoid may exist in low-grade contact metamorphic facies if composition exists. The absence of cordierite plus andalusite distinguish this facies from hornblende hornfels facies. The albite, epidote, hornfels facies was proposed to cover mineral assemblages as they begin to form in the outermost fringe of the contact areoles. The talc Mg6 Si8 O20 OH4 appear as the first silicate phase in metadolomites of some areoles, and antigorite Mg3 Si2O5 OH4 serpentine has been similarly recorded in areoles in serpentinite, for example, Tele 1951b. Andalusite, commonly seen in spotted slates far from visible platonic contact, appear to be a stable phase in some peltic assemblages of the albite, epidote, hornfels facies. The paragenesis recorded in the outermost part of the Tono areoles, Japan, Siki 1957, tends some support to this possibility. In such a situation, to place the first appearance of andalusite in the albite, epidote, hornfels facies would be hardly better than a guess consist with the textural evidence and dimension of areoles. With such qualification in mind, chemographic phase relation in the albite, epidote, hornfels facies can be initiatively depicted in the figures, tentatively depicted in the figures ACF, AKF and AFM diagrams, and carbonate assemblages in CO, MgO, SiO2, CO2, S2O diagrams. Typical assemblages shown in figures ACF, AKF and AFM are: A. Peltic assemblages, pyrophyllite, andalusite, muscovite quartz. Second, andalusite, muscovite, biotite plus minus pyrophyllite quartz. Third, biotite, chlorite, muscovite, quartz. B. Quartzo-feldspathictic assemblages. Number 4, biotite, muscovite, microcline, quartz. C. Basic assemblages. Number 5, albite, epidote, actinolite, chlorite, plus minus quartz. D. Calcareous assemblages. Number 6, epidote, calcite, tremolite, plus minus quartz. Number 7, calcite, epidote, plus minus quartz. Number 8, calcite, tremolite, plus minus quartz. E. Ultramafic assemblages. 9, talc, tremolite, chlorite, magnetite, plus minus serpentine. F. Calcareous assemblages on the basis of CO, MgO, SiO2 diagrams. Number 10, calcite, dolomite, quartz. Number 11, calcite, talc, quartz. Number 12, calcite, talc, dolomite. Number 13, calcite, tremolite, dolomite. In this lecture, I will proceed under the following heads: pressure, temperature, condition, and metamorphic reaction, along with summary. Hope it will be useful for you. Try to be regular in course. The kaolinite and quartz react and form pyrophyllite plus water, characterize the beginning of albite, epidote, hornfels facies. Kaolinite plus quartz give rise to pyrophyllite plus water. This reaction was carried out by Thomson in 1970, 325 degrees centigrade 1 kilobar, 345 degrees centigrade 2 kilobar, and 375 degrees centigrade 4 kilobar. A certain rise in temperature has no effects on the stability of pyrophyllite, but shortly before the beginning of the hornblende hornfels facies, the following reaction take place. Pyrophyllite give rise to andalusite plus quartz plus water, that is reaction number 2. This reaction was carried out by Carrick in 1968, 400 degrees centigrade 1 kilobar and 430 degrees centigrade 3 to 5 kilobar. Another reaction, dolomite plus quartz plus water give rise to talc oblique tremolite plus calcite plus CO2. This reaction was carried out by Winkler in 1976. According to him, this reaction may proceed talc or tremolite depending on the water content at 400 to 420 degrees centigrade 2 kilobar. Under upper temperature limit can be shown by the following reactions. Chlorite plus muscovite plus quartz give rise to corderite plus epidote, biotite plus aluminosilicate plus water, reaction number 4. This reaction was carried out by Horsberg and Winkler in 1968. Ale-rich chlorite plus quartz give rise to gaderite plus corderite plus water, reaction number 5. This reaction was carried out by Akela and Winkler 1966 at 550 degrees centigrade 1 kilobar and 560 degrees centigrade 2 kilobar. Chlorite plus tremolite plus quartz give rise to hornblende plus anthophyllite plus water. Same pressure and temperature condition as reaction 5, 550 degrees centigrade 1 kilobar and 560 degrees centigrade 2 kilobar. By Chaudhary and Winkler 1967. These reactions suggest temperature ranging between 300 degrees centigrade to 450 degrees centigrade to 500 degrees centigrade during metamorphism in albite, epidote, hornfels facies. Pressure condition range between few hundred bars to about 4 kilobar. The upper pressure limit is indicated by the absence of kyanite and more common presence of andalusite suggest pressure of less than 4 kilobar. Therefore, below the pressure limits of triple point of Al2SiO5 by Holdway 1971 at 501 degree centigrade 3.76 kilobar, and second, the absence of almandine garnet and kyanite in low pressure environment of metamorphism suggests of less than 4 kilobar pressure or so during metamorphism of albite epidote hornfels facies, because almandine garnet formed by the reaction chloride plus muscovite plus quartz give rise to almandine plus biotite plus aluminosilicate plus water at 500 degree centigrade 4 kilobar and 600 degree centigrade 5 kilobar by Horsberg and Winkler 1968. However, almandine garnet is also reported from some thermal areoles by Sinner. The absence of almandine in low pressure condition also suggests pressure less than 4 kilobar, Su 1968. Thus, absence of almandine and kyanite in low pressure environment of metamorphism suggests of less than 4 kilobar pressure or so during metamorphism of albite epidote hornfels facies. The course content on metamorphism of low pressure metamorphic facies begin with introduction, followed by the description of albite epidote hornfels facies, the important characteristic minerals in this facies, the chemographic phase relations with the help of ACF, AKF, AFM and CO, MgO, SiO2 diagrams, and mineral assemblages for peltic, quartzo-feldspathic, basic, calcareous and ultramafic rocks, and finally the pressure temperature condition of metamorphic reaction during albite epidote hornfels facies. Thus, absence of almandine and kyanite in low pressure environment of metamorphism suggests of less than 4 kilobar pressure or so during metamorphism of albite epidote hornfels facies, and temperature varies from 300 to 450 to 500 degree centigrade. For further studies, please read the textbooks, references and links given in the text. Thank you.